Alright, so this is the video on real numbers, and it's it's something that you've probably learned before. You go over in Algebra 1, and then we go over it usually in geometry when we're reviewing for aims, and then you might even touch on it in Algebra 2, I don't know. And so it shouldn't be new, but it's worth going over because it is on it, okay? And so what it is the real number system is we like to classify different numbers into different groups. So we want to classify the negative numbers, numbers that involve negative numbers or fractions or just positive numbers. How can we classify these different groups of numbers? And we have names for them. Okay, and so basically, it's kind of a tree, and it branches out into smaller and smaller groups. And so the very top of this tree of numbers is the real numbers. Okay, and so let's write that up here. So we got the real numbers. Okay, and so basically everything is a real number. Okay, and then it breaks off into two subgroups. Okay, and so the first one, and we'll talk about this one first because it's only got the one. So this one's going to break off to the right, is what we call the irrational numbers. Okay, you get the irrational numbers. All right, and so the irrational numbers, and there's some common ones, but basically the definition of an irrational number is a number that cannot be written as a fraction. So if you cannot write the number as a fraction, then it is an irrational number. So like, for example, 3/5 is not an irrational number because that's a fraction. So the common ones for irrational numbers are things like, the most common ones are pi, because pi is a decimal that goes on forever. You can't write pi as a fraction. Okay. Another irrational number, another kind of way they do irrational numbers is decimals that don't repeat. So pi is a decimal that doesn't repeat, but usually you don't always think of it like that. But a number like 3.89711035, that is an irrational number, and we would have to put the dot here, because it never repeats and it doesn't stop. It goes on forever. All right. So that is an irrational number. Okay. So the other type of number that branches off. So you can either go to the right and be an irrational number, or you can go to the left, and if you're not irrational, then you're a rational number. Okay. And basically, rational numbers are all the numbers except for the irrational number. So it's basically a rational number is any number you can write as a fraction. So it can be positive, it can be negative. So like 3/5 is a rational number. 0 is a rational number. Okay. Let's think of something. -2 is a rational number because -2 could be -2/1. That could be written as a fraction. One that's kind of tricky. If you had something like 3.3 and we put a bar over it, so 3.3 with the bar over the top, that means 3.3333, right? And on forever. You say, well, why isn't that an irrational number, right? It's a decimal that goes on forever, like over here. That should be an irrational number. The reason something like this, when you have a repeating decimal, why that's a rational number, not an irrational number, is because you can write that as a fraction. The way you would write that as a fraction is like this: 3/1/3. Okay, and if you don't believe me, we can check the calculator. So 1/3 is 0.333. So 1 divided by 3, and there you go. It's 0.33333. So whenever you have a 1/3, or basically whenever you have a repeating decimal, that's going to be a rational number. Okay. And then from there, we break off into more groups. So the next group we're going to break off into is what we call integers. Okay. So you get your let me see if I can spell this. Integers. Okay, and what integers are what we call positive and negative whole numbers. So you can't have fractions like 3/5, or you can't have decimals basically. No decimals involved here. So your integers are things like -3, -2. I guess we put -1 there. -1, 0, and then you could also have your positive numbers: 1, 2, 3, and these go on forever. But what you're not going to have in here is 3.2 or 6 5/8. or negative 3.1. Those aren't going to be integers. So these are, the way to remember this is positive and negative whole numbers. Okay? And then from integers, we take a subgroup of these and we call them the whole numbers. Okay? And whole numbers are always positive. Okay? So a whole number is, it includes 0. Okay? And then it's just 1, 2, 3, and these go on forever, right? Basically it's just not negative integers. All the positive integers is the way to think of a whole number. All right, and then the last one down here is real similar to whole numbers. It's called the natural numbers. And another way we always teach natural numbers is we call them the counting numbers. Okay, and so when you start to count, if you're going to count the number, of shirts you had in your closet, you would start with number 1. You wouldn't start with 0. You wouldn't go 0, 1, 2, 3. You would start with 1. So the counting numbers, or the natural numbers, are basically the whole numbers except for 0. So they start with 1, go up 2, 3, dot, dot, dot. Okay, and so these are our real number systems. And so you would have to be able to classify the different ones. So if I said, what is the number 3? Classify the number 3. Well, the 3 is a whole number, or a natural number. It's also a whole number. It's also an integer, and it's also a rational number. It could also be up here, right? 3 can be written as a fraction. Okay? The only thing 3 is not is an irrational number. Okay? And so, if I were to classify the number pi, the only thing that pi is an irrational number and a real number. Okay? It's not none of these, right? So, those are your real number systems. So let's try some problems here and get the hang of it, see if we can catch on to what's going on. All right, so this first one, negative 3, we're gonna classify it as many ways as we can. So negative 3 is negative, so the negative numbers, it can't be a whole number or a natural number, but it could be an integer. Okay, so an integer, and it could be a rational number as well as a real number. Okay. 1.333, again, this is that repeating decimal, so that's going to be 333 forever. So that is a rational number. It's not irrational, it's rational. Okay, and again, it can't be an integer because it's got a decimal, and the same reason for whole and natural. So this is just a rational number and a real number. Okay? All right, the number 2. This is going to basically be everything, because number 2 is a natural number, which means it's also a whole number, which means it's also an integer, which means it's also a rational number, and then everything is a real number. Okay, everything's always going to be a real number, so we can add that on. Okay, 2/3. Okay, it can't be natural, can't be a whole, and it can't be a integer, because those can't be written as fraction, but it is a rational number. Okay, because it has written as a fraction, so it's a rational and a real. Okay. Go on here. Pi, whenever you see pi, that one should always come out to you. Pi is a irrational number. Oh, square root of 2. This is something I did not talk about. Okay, so let's go back here real quick. A irrational number, these are the common ones. The other one are things like square root. Okay, so the square root of 3 is also rational. If you do that on your calculator, so let's see if I can show you here on the calculator. The square root of 3, let's say. So this is how I do it here. Where's my square root button? It would be this one, I believe. So there you go. That's what it equals. 1.7. And you can look at this decimal. It shows that it stops here, but in real life, this keeps on going forever in this direction. So these are irrational numbers because they're going to be, decimals. You can't write the square root of 3 as a fraction. Okay. All right. So back to this one. So again, we just kind of said that. So this one's also irrational. Okay. But a trick one they might get you with is something like the square root of 4. Okay. So the square root of 4 is that irrational. Well, what does the square root of 4 equal? If you don't know this already, the square root means what times itself equals 4. So the square root of 4, well, 2 times itself equals that. So the square root of 2 is actually not irrational. Or the square root of 4 is not irrational. It could be rational, whole number, integer. It could be all of those. Okay, and then 0. The only one 0 can't be is the natural number, but it could be a whole number, an irrational or an integer, a real number, and a rational number, right? So we got rational and real. Okay, so let's look at some Ames questions and see how we do. All right, so it says here, this is practice one. It says the set 0, 17, negative 29, negative 79 belongs to which subset of real numbers? And so irrational, right off the bat, I could say, well, irrational numbers can't be written as fractions. I see some fractions there, so it can't be A. Integers, okay, integers, they can be negative. 0 and 17, those are integers, but integers are not fractions, so I can cross out that one. All right, natural numbers can't be negative. And so the last one would be the correct answer, rational, because they are all written as fractions, right? 17 over 1, 0 can be written as 0 over 1. Those are all fractions, right? And so that's all it has to be a rational number. Okay? Let's look at another one here. It says, which number is an irrational, which number is, I guess I should just say which number is irrational. And so again, an irrational number cannot be written as a fraction, okay, or it's in a repeating decimal, or a non-repeating decimal. A decimal that goes on forever, but it's not repeating. Or a square root of a number that is not a perfect square. Okay, so this first one, 3.34, that is a rational number, right? That decimal does not come on forever, right? So that one is not an irrational number. Here, you got the decimal that goes on forever. However, it's a repeating decimal, and therefore it's rational. Okay, so this is not irrational. You look at this one, you got 0, 2, 5, 4, 6, 9. That doesn't look like it's repeating at all, and it's going on forever. So that means it is irrational. Okay? And then the last one, D here, okay, that's written as a fraction, so that's obviously not the answer. Okay? And so that's the video on the real number system. If you need help, rewatch it again, or if you feel comfortable with the material, go on and try the practice, and then take your assessment.